So in class today, you guys were working on a group challenge where I asked you to sort of get used to the concept of the mole and how the mole represents a number. And so that's an important thing for us to make sure that we continually reinforce. Because obviously, a mole of elephants is significantly heavier than a mole of naked mole rats, or no, star-nosed moles. But if we're just talking about the number, there are an equal number of elephants, if you have a mole of elephants, than there are to star-nosed moles, which are, if you have a mole of those star-nosed moles as well. So now let's take it a step further, and we're going to start looking at how to convert between the number of moles of something and the number of particles of something. So let's imagine that we have a problem like this. Okay, so here's a problem that's taken from a worksheet. In fact, this is probably a worksheet that many of your peers in other classes are using. And so you can see here it says determine the number of formula units that are in 0.688 moles of silver nitrate. Now, for those of you who are in my D block class, you might not understand the concept of a formula unit. And actually, maybe the C block class, that's what I meant. Maybe both classes don't know. A formula unit is what we refer to when we're talking about a ionic compound, which is the case with silver nitrate. So if I were looking at something like water, for example, I wouldn't refer to water as a formula unit because it's a molecule. You would refer to it, therefore, as a molecule. The reason why we talk about these things as being formula units is that don't forget that the silver nitrate, when it's in its solid form, is a crystal structure. So it has alternating silver and nitrate ions that are all sort of jammed together in a checkerboard-like pattern. But if we want to just talk about a single silver ion combined with a polyatomic nitrate ion, then we refer to that as being a formula unit. Okay? So when we're dealing with moles, we talk about atoms, we talk about formula units, we talk about molecules. Okay? So I want to determine the number of formula units that are in this number of moles, 0.688, of silver nitrate. Now the beauty of this is that the only number you need to have in your brain is 6.022 times 10 to the 23rd. And you know that you have this equivalency, that 1 mole of anything is equivalent to 6.022 times 10 to the 23rd of whatever that particle is, or whatever that piece of matter is. It could be elephants, right? And as long as you have this equivalency, you understand, I hope you can understand this, that if I had 1 mole of whatever it is, let's just call it substance X, and I divided that by 6.022 times 10 to the 23rd of those, well actually no, I'm not going to put X there, that's kind of dangerous, let me get rid of that, okay, that's the number of particles, that because those are equivalent, 1 mole and 6.022 times 10 to the 23rd, in a sense, no, not mathematically, but in a sense, this equals 1. And that's important for you to understand. Because that means that I could also do just the reverse. I could take the 6.022 times 10 to the 23rd, and I could put that over 1 mole of whatever substance X we have here, and that too is going to equal 1. Now that's going to become a really useful tool for you as we move forward, because if you put these things into parentheses, they are equivalent to each other. And if you're multiplying something by 1, you haven't really changed that thing in any sort of way. So let's take a look and see how this applies to what we're going to be talking about here. If we know that we have 0.688, and by the way, Selden today in class asked, do we need to worry about significant digits? And I said, for the worksheet that we were doing today in class, you didn't, and this was on Tuesday, because I'm sure you guys are viewing this on Wednesday evening, that you don't need to worry about sig figs, but now you do. sig figs are going to become your friend. And if I have 0.688 moles of something, in this case moles of silver nitrate, then I have 3 sig figs. Don't forget that. The other thing you really need to get in the habit of doing is not leaving off this part of it, because you can get really lazy and leave off these things, but as soon as you take those shortcuts, you're inevitably going to make a mistake, leave something off, mix something up, etc. So don't do that. Make sure you always put in the appropriate units. Okay, so I want to know the number of formula units that I have of something. And that means I want to make sure that my unit is the number of whatever the particle is, formula units in this case. So if I'm going to use an equivalency, I'm going to use one of these two equivalencies that I've written just above it. And in fact, if I want to make sure that my moles disappear in the end, I'm going to be sure that I use this one. And I'm going to snuggle it right down here. However, I'm going to follow my own advice, and I'm not going to get lazy about this. And I need to make sure that I write down that I have moles of AgNO3 here. Let's just extend this. And we can just say, whoops, I didn't mean to write a P. Formula units. Okay. So you can see that if we go ahead and plug this into your calculator, that we're going to come out with formula units of something, because in fact, if we take a look at this, this and this will cross out, right? You'll lose those two units and be left with formula units. Okay, right there. All right, so I stick this into my calculator. Now, if you don't know how to put in scientific notation into a calculator, you're going to be using that capital E button. That is, so you type in the number, something like 6.022, then you hit the capital E button on your graphing calculator, and then you hit 23. Now, let's say if it was a negative number, it was 10 to the negative 23, then you have to make sure that you use the plus minus sign button to put in the appropriate number. But in this case, it's positive 23. So 6.022, then hit double E, 23, and you multiply that by 0.688. And if you do that, you should get, if my math is correct here, 4.14 times 10 to the 23. I can't fit it in there. Formula units of AgNO3. Okay, notice here that I have 3 sig figs in my answer. And I also want to get in the very good habit of circling my answer when I'm done. Okay, all right, let's do one more of these things. Fresh page here. And I'm going to do it in just the opposite. Okay, so in this case, I'm going to ask the question here. I'm going to pause it for a moment and write out the question. All right, so here's my question. How many moles of ethane contain 8.46 times 10 to the 24th molecules? Now, don't forget that a mole of something is 6.022 times 10 to the 23rd. So just purely using common sense here, you can see that we're going to have more than 1 mole, greater than 1 mole. So you should always do those common sense checks with your final answer when you come up with it. But as you go into this, you should also know that since that number is greater than a mole, 6.022 times 10 to the 23rd, that you're going to have more than 1 mole. All right. Now, the other thing that's important to point out here, in these questions in particular, it's not always going to be the case. In these questions, it really doesn't make a difference what this is, right? I could have put in here, how many moles of Triscuits contain 8.46 times 10 to the 23rd Triscuits? All right, but I haven't done that because obviously this is a chemistry class. But the important thing, the reason I point that out is that it really doesn't make a difference what this is, because I want to know the number of moles in a given number of particles. Okay, so it's just like I want to know how many dozen I have in 144 hats. Same concept there. It doesn't make a difference if it was hats, pillows, cameras, matches, etc. All right, so how do we set this up? Well, you're always going to start with the number that's given to you. So that's 8.46 times 10 to the 24th molecules of ethane. Okay? And then I need an equivalency here. And again, the equivalency we're working with is either going to be 1 mole over 6.022 times to the 23rd, right? Or it's going to be 6.022 times 10 to the 23rd over 1 mole. If you look at this situation, we want to figure out how many moles we have. So that means we want to make sure that we put moles as our numerator. So 1 mole of C2H6, and we know that 1 mole of C2H6 is 6.022 times 10 to the 23rd molecules of C2H6. Right? So again, you're going to do the same thing with your calculator. 8.46 double E 24 times 1, obviously it's the same thing, divided by 6.022 times 10 to the 23rd molecules of C2H6. And if you do this and your calculator is working properly, you would end up with the answer of 14.0. Very important, you have that 0 in there. It's a placeholder, but it's meaningful. 14.0 moles of ethane are produced. Okay, and circle up the answer. By the way, you don't always have to write out the word moles, as I've done right there. You can just shorthand write MOL for moles. Be very careful, however, that you don't confuse that with molecules. Notice that I've written out molecules, or I've written a significant chunk of it, so you know that I haven't written moles, I've written molecules. If you go shorthand on molecules and moles, obviously they start with the first 4 letters. It's not going to help you, so you got to keep going with that. Okay, so I think you have a pretty good understanding of how to go back and forth between moles and number of particles, whether it's formula units, atoms, or molecules. So we'll stop there, and I expect that we're going to have an opportunity in class, perhaps even in some worksheets, to practice doing these things. But these are pretty straightforward, so you shouldn't need too much in the way of practice. All right, see you guys Thursday for lab. Don't forget, tie your hair back, closed-toed shoes, and come with an iPad fully charged. Bye.